Alright guys, number one, these problems, by the way, bearing in mind, these problems are mostly on 5.4. Your chapter is all of chapter 5 and 6.2. So if we don't cover it here, but it's on the test, that's why this is not a 100% review sheet, but I think this is the stuff you struggled with the most. Okay, so the first problem, numbers 1 and 2, ask you to evaluate the integral by differentiating the result, and then by using the second fundamental theorem of calculus. So I'm going to go ahead and say, let's just skip this part because we already are going to do that down here, and let's just evaluate the integral and then take the derivative. That's going to help us with 6.2. You need to know these rules from 6.2, how to integrate them. So let's just look at number 1 first. If I integrate, forget the bounds for a second, if I integrate cosine of t, that's a rule that I need to know. The integral of cosine of t is sine of t, because if I took the derivative of sine, I would get the cosine. Okay, second fundamental theorem says, okay, turn this integral into a bar. Here's x squared, here's 1. Plug in x squared. So we're going to get sine of x squared minus plug in 1, sine of 1. All right, now we're going to go ahead and we're going to take the derivative of this, because this is really a first fundamental theorem of calculus issue. So I'm going to take d dx of this whole answer, sine squared of x minus sine of 1. And this is a derivative. This is first semester. The derivative of sine of, I totally made a mistake. It's not sine squared of x. It's sine of x squared. Big difference. So the derivative of sine of x squared would be the cosine of x squared times the derivative of x squared, which is 2x, plus the derivative of sine of 1 would be 0. So this whole answer would be 2x cosine of x squared. All right, number 2, we're going to do the same thing. Once again, I'm only doing this now because it practices your 6.2 rules. So basically, we want to integrate u to the 1/2 du, which would be u to the 3/2 divided by 3/2, which is times 2/3. Okay. Now we want to go ahead and plug in our x squared, I believe it is on top, and then 1. So I'm going to go ahead and plug that in. If I plug in x squared, I've got u, I apologize, not u. I have x squared to the 3/2 times 2/3 minus, now I'm going to plug in 1 to the 3/2 times 2/3. All right, okay, so whatever this happens to be, this is 2/3 x squared to the 3/2. 2 times 3/2 is 3, so this would be 2/3 x cubed minus 2/3, because 1 to any power is just 1. Now let me go ahead and do what the second part they told me. Take the derivative of this answer. And if I take the derivative of this answer, I'm going to bring down my 3. I've got 2x squared. And I've derivative of negative 2/3 is 0. So that's going to be exactly what we would get here. Okay. All right. So number 3. Okay, sorry, I apologize. Number 3, we would get it. I just want to show you what would happen here. I had to check for a second. We had learned, and we're going to do that right now. Take this, plug it in here, right? So it would be x squared and the square root times it by the derivative, which would be 2x. X squared and root cancel out, so it's just x. X times 2x is 2x squared. So that's exactly what we got over there. Now we're going to use that shortcut on these problems 3 through 8. And they want us to use it to find the derivative, basically f prime of x. So we're finding d dx of all these numbers. It says if we have a number on the bottom, a variable on top, plug the variable in. So that would be 1 over 1 plus x squared, and multiply by the derivative of our variable, which in this case would be 1. So we would be done. Number 4, it's almost perfect, except this is switched. we want the number to be on the bottom. So I'm going to switch it by making it negative, and now I'm allowed to flip it. And now I can do what I just said. Take the variable on the top, plug it in to t, and multiply by its derivative. So we got negative 3x sine x times 1, which would just be 3x sine x. Okay, once again, we're going to flip it. So I'm going to make it negative 0 to root x sine of t squared dt. Now it's flipped, I can plug in. So I got my negative from up front. I'm going to plug in sine of root x squared. And then I'm going to multiply by the derivative of my root x. Let's just look over here. The derivative of x to the 1/2 power would be 1/2 x to the negative 1/2. So that is, I'm going to multiply by 1/2 x to the negative 1/2. If I just go ahead and clean up that answer a little bit, I've got negative sine of x over 2, and this goes down to the denominator, root x. All right. I believe it says tan of theta here. Is that what that says? And that says pi. Okay, so tan of theta. Now look at here, right here. We've got f of x, and we've got tan of theta. So we're taking d dx of this. And we don't have an x on either bound, not one at all. So we can't actually use the fundamental theorem. That means both of these are just numbers. And if I was to take the derivative of a number, I would just get 0 as my answer. So that's kind of a little trick question. No x's right there. Okay, this one, number 7. This is we have two variables, x cubed and x squared, and we want to break those apart. So we're going to rewrite it. We're going to split it up. We're going to insert a number of cosine of 2t dt. We would have, from x squared to 0 of cosine of 2t dt. And once again, we do not like this, the variable being on the bottom. We want to flip it up to the top. So that means we're going to go back, and rather than rewrite it, I'm going to switch them right here. I'm going to switch them, and I'm going to make it negative. So now when I write my answer, I'm just going to plug in my variable, cosine of 2x cubed, and multiply by my derivative of that number I plugged in, which is 3x squared, minus, because I changed those signs, I'm going to plug in x squared, so cosine of 2x squared times the derivative of x squared, which is 2x. Just so that it doesn't get confusing, we'll probably just put these back here at the front. So this would be 3x squared cosine of 2x cubed minus 2x cosine of 2x squared. All right, very last one. We're going to have to do that twice again, and we've got that nice fraction. So we're going to split it up. Hopefully by now, do you see that there's a pattern that it's always the top one is normal, but the one that was on the bottom when we plugged it in, it became negative. So I'm just going to kind of follow that pattern right now. This will equal, so I'm going to plug the first one in, the top one in. So it's 3x, the whole thing, squared minus 1, over 3x, the whole thing, squared plus 1, times the derivative of what I plugged in, which was 3, minus, because now I'm going to plug in that second one, 2x, the quantity squared minus 1, over 2x, quantity squared, plus 1. And then I have to multiply it by the derivative of 2x, which is 2. All right.